Okay, today we're just looking at the difference between empirical and molecular formulas. And we went through this yesterday, but the explanation that they have in the textbook, which you're seeing on this screen, to my mind, is a little muddy. It's very precise, no question about it, but it's a little muddy because it doesn't really get you the idea of what's happening. So let's look down here, empirical versus molecular. Here I have, oops, I wanted to get rid of this. Okay, here I have an empirical formula on the left, and on the right, you see the molecular formula. Okay, so I'm going to call on someone, and let's see if we can get the number. Ruben's not here. Jason, you're good. Go for it. What do you think the value of n is for the empirical versus the molecular formula? In other words, how are we going to get the empirical formula to match the molecular formula? Multiply by 2. Yes, and I'm sorry I had that on the screen already. But I want you to understand what you do when you multiply by 2. Multiply by 2 means that there's 2 of these dudes. Okay, not just one. There's 2 of them. And if there's 2 of them, what that means is that the subscripts, so, like you said, the 2 down there is because when we get 2 of these guys, we're going to have 2 hydrogens and 2 oxygens. So you are literally, when you put this 2 out here for n, you're literally multiplying the entire molecule. Yes? It's the smallest ratio of atoms. And it's kind of the simplest form. You could say it both ways. But I wanted to inject that ratio thing in there for you. But you're absolutely right. You're absolutely right. Okay, let's go on and let's look at a second one. Okay, so the value of n we realized was 2. So I'm going to get rid of that so I don't have it there next time I go to the screen. And now we're going to have molecular and empirical. I switched sides on you this time because I'm going to give you, come on, there we go. I'm going to give you the molecular formula, and then we're going to figure out the empirical formula, and that is another way of finding the value of n. So, Selena, here we have the empirical and molecular formulas, and as you look at the glucose molecule here, which is what this stuff is, and you look at carbon, hydrogen, and oxygen over here, what number could you divide all those subscripts by to simplify this guy?
1.
Shh. What? Okay, would that be the simplest form? Let's try it. 3, 4, and 3. Is that the simplest that we could go? Wait, 3, 6, 3, yes. Yeah, okay. 3, 6, and 3. And now we can divide by?
3.
Yeah, and what's the numbers?
1, 2, 1.
Yeah, 1, 2, 1, and we don't have to write the ones. So all we do for the empirical formula is get it like this. Did you have a question? Yes? We should have, but that's okay. She got to it, all right? But yeah, she was right. We could divide it by 2, but we want to get down to the smallest possible ratio. Okay? So Selena, you could probably get that in one shot next time, right? Yeah. Okay. Good. So that's your deal on how to find the value of n in this way.